Hello friends, welcome to lecture number 40. In today's class, we will study about force between two parallel current carrying conductors. Okay, so here we have taken two conductors, conductor 1 and 2. Here you can see the direction of the current is same, that's why we call it as parallel current carrying conductors. One, the current is I1, the other one is I2. The what is R? R is your separation between the wire. Okay, and there is a L. L is what? L is the length of the wire. L is your length of the wire. Okay, fine. So let us try to see what will be the magnetic field and then what will be the force. Let us think about I1 only. There is no I2. Forget about I2. Only I1 is there. Current direction is up. Keep the thumb in that particular direction. If you curl your fingers, you will see to the right of I1, the field lines, magnetic field lines is into the plane of the paper, and to the left it is moving away from coming out of the plane of the paper. Therefore, you can see this is represented by dot here, again cross here. Is it clear why dot and cross I have put? Fine. Then let us consider current I2, forget about I1. There what we'll do, again put the thumb in the direction of I2, curl your fingers, then you'll see to the right of I2, the magnetic field lines is entering into the plane of the paper, and from the other side it is coming out. So it is cross here, and here this is dot. Clear? Then we have to find out the force. Okay. Now, because of the current in I1 current, there will be a magnetic field. Okay, and what will be the magnetic field? It will be cross, right? Once you have the magnetic field, because of the magnetic field, there will be a force on the second conductor. Okay, so let me name these conductors. Instead of naming it 1 and 2, let me name it. This is AB. Let me name it as AB conductor, and this is CD. Okay, so let us now first find that because of the current I1, there will be a magnetic field produced, and that will be experienced by the second conductor, that is CD conductor. Okay, then what is the magnetic field? Let us find out that. So you can write here the magnetic field produced by current I1 at any point on the wire CD is B1 is equals to mu naught I1 divided by 2 pi r. This we have already derived. And what is the direction of the magnetic field? It is cross. I have shown it here. It is cross. Okay. Then this magnetic field exerts a force on the wire CD. Then F2 will be how much? Let us see what should be the direction of your F2. Okay, that means the force on the CD wire. Followed? Now you see here the magnetic field is into the plane of the paper. Okay, force is I into L cross B. L you take it in the direction of the current. So all the four fingers are moving upward in the direction of I1. Then what you have to call inward or outward? You can see the magnetic field is into the plane of the paper. So you curl your fingers into the plane of the paper. Where is the direction of the thumb? You can see the direction of the thumb will be in this direction. This is F2. Okay. So what will be my F2? F2 will be equal to I2 L B1 sine 90 degree. Why 90 degree? Because magnetic field is perpendicular to the current element. Okay. So sine 90 is 1. You will have I2 L, and what is B1? You have just now found out, mu naught I1 by 2 pi r. Okay. So if you write F2 will be how much? F2 will be mu naught I1 I2 L divided by 2 pi r. Okay, so this is the value of F2, and you have also found out the direction of F2. Then force per unit length, how much it will be? Then force per unit length, okay, is, it is denoted by small f. Small f will be equal to F2 by L, that will be equal to mu naught I1 I2 divided by 2 pi r. Okay, so this is the expression for your force per unit length. Followed. Now this we have done for I1. Similarly, we have to consider the current I2. Because of the current I2, there will be a magnetic field B2, and what will be the direction? It will be, your B2 will be where? Dot. That means moving away. Okay. So how will you calculate the force? All the four fingers will be in the direction of I1. Then you move up because the magnetic field is dot. That means it is coming out of the plane of the paper. So you call all your four fingers of your right hand, and you'll see the thumb will give you the direction of the force. And what is the direction of the force? It is F1, in this direction. And looking at F1 and F2, you can easily say they are in opposite direction, and they are attractive. They are attracting each other. So we say the parallel currents attract. So let us find out. Similarly, we can write considering the current I2, considering the current I2 in the where CD, the magnetic field B2 will be how much? Mu naught I2 divided by 2 pi r. And what about the direction? It will be dot. Okay. So now what will be the force? What will be F1? F1 will be the force on where AB due to the current I2 in the where CD. Okay, it will be how much? I1 L B2 sin 90 again. Okay, sin 90 is 1, that is gone. So I1 L B2 is how much? Mu naught I2 divided by 2 pi r. So what will be F1? Mu naught I1 I2 divided by 2 pi r into L. This is the value for F1. Okay, then what will be your force per unit length? F, small f, F1 by L, that is equal to mu naught I1 I2 by 2 pi r. Okay, so if you compare F1 and F2, you can see the magnitudes are same. Okay, their magnitudes are same. So if I give it as equation 1, I give it as equation 2. So I can write from equation 1 and 2, from equation 1 and 2, we find the force magnitude is same, and looking to its direction we can say parallel currents attract. Okay, and what about the equation? We can say F1 vector is equal to minus of F2 vector. This is very true. Okay, directions are opposite. Clear? Okay, this is all about your parallel current carrying conductors. Okay, now what will happen if there are anti-parallel current carrying wires or conductors? For anti-parallel current carrying conductors or wires? Conductors. Okay, clear? when it is antiparallel. So again, let us draw a diagram, a familiar diagram. Suppose I am having a wire or conductor of this fashion. Antiparallel means that if one current is going up, I1, the other current will come down, I2. This is A, this is B, and this is CD, as usual. So first, what is our job? That I take I1 in up, so thumb will be in the direction of I1. I'll call all my fingers, so I find this side it will be cross, this side will be dot. For this I2, this side will be cross, this side will be dot. Okay. Now what about the directions? That is very important. Because of I1 current, the force on CD will be how much? You see, current all the four fingers will be up and it is into the plane of the paper. So a force will be in this direction. Okay. So what we can say here, F2 will be in this direction. Okay. And what about F1? It will be in this direction. So what about the derivation? If it comes for an antiparallel in the CBSE, for antiparallel, the derivation is exactly the same. Everything will be same. Okay, just in the diagram, the difference is here. This is the F1, here it is F2. And from the diagram, what is clear? That your antiparallel currents repel. You see that the forces, they are repelling each other. Okay, so we can say one thing for the antiparallel wires, that antiparallel currents repel. Okay, antiparallel currents repel. Followed. Now this comes as a long question. Along with it, it comes define ampere. Okay, so I give a heading, definition of ampere. Okay, which is the unit of the current. Basing upon this, we have to define current. Okay, definition of ampere. So when I1 is equals to I2 is equal to 1 ampere and R is equal to 1 meter, then your F will be equal to how much? Mu naught by 2 pi, which is equal to 2 into 10 to the power minus 7 Newton per meter. Okay, so basing upon this, we will be defining it. So we can define 1 ampere is that value of steady current, which on flowing in each of the two parallel infinitely long conductors of negligible cross section placed in vacuum at a distance of 1 meter from each other produces between them a force of 2 into 10 to the power minus 7 Newton per meter of their length. Okay, so this is how you can define. So this comes for 1 mark and the derivation comes for 2 marks. So it will come totally combine up to 3 mark question. Okay, is it clear? So now after this, let us do a small problem related to this. Okay, the common question. This comes for 2 marks. So 2 marks for derivation, 1 mark for the definition of ampere, and then this followed by the problem. So this will be total your 5 mark questions, and it is very easy to get all the 5 marks also. So the question is, two straight wires A and B of length 10 meter and 16 meter and carrying currents 4 ampere and 5 ampere respectively. 5 ampere respectively in opposite direction. In opposite direction. That means antiparallel. Okay? Opposite direction. Comma. Lie parallel to each other 4 centimeter apart. Okay, the question is compute the force on a 10 centimeter long section of the wire B near its center. Okay, so this is the question. Now how to go about it? So we know that your force per unit length F by L will be how much? The formula mu naught divided by, instead of 2 pi, let me write it as 4 pi. Then here there will be 2 I1 I2 divided by R. So what is this mu naught by 4 pi? We know it is 10 to the power minus 7 into 2 into 4 ampere into 5 ampere divided by R. R is 4 centimeter. That means 4 into 10 to the power minus 2. Okay, this will be equal to, so 4 gets cancelled out. 5 2 are 10, 10 to the power minus 6, minus 2, it will go up, plus 2, so it becomes 10 to the power minus 4 Newton per meter. Okay, now if it is asking to find out force on a 10 centimeter length of the wire. Okay, that will be equal to how much? 10 to the power minus 4 into the length. Which length? 10 centimeter, that means 0.1 meter. This gives you 10 to the power minus 5 Newton. Okay, so this is the required force which is going to be exerted. Okay, so this is it for today's class. I hope you all must have enjoyed it. Do not forget to subscribe my channel, and any queries you have, you can mail me in the mail ID which is given below. Okay, thank you for your kind patience.